Hello, we are Team P2C255, a senior design team at RIT. Our project is about optimizing electrode tap cleaning for battery production.
For our project, we're working with RIT's Battery Development Center to address a key issue in battery manufacturing, which is slow and inconsistent electrode tab cleaning. The current process is done manually by an operator, which leads to variability, reduced weld quality, and unnecessary material waste. Our objective is to standardize this process by improving consistency, reducing cleaning time, and ensuring reliable, weld ready tabs through a semi automated system while also enabling inspection and data logging for traceability. Currently, electrode tabs are cleaned manually using a solvent and a Q-tip, taking around a minute to clean just one of the two sides. As seen with this sped up footage, this process requires multiple passes, which makes it difficult to achieve consistent results across different operators and batches. It's also time consuming and often leads to uneven surface quality, which can negatively impact weld performance.
After going through a few initial design choices, our team ended up with a semi-automated tab cleaning process using a rotary abrasion tool to clean the tabs. This consists of a Dremel motor with a fixture to hold the tab in place and a gantry to move the tab from the cleaning side to the inspection side. For the inspection side, there is a YOLO AI detection model that can determine the difference between clean tabs and unclean tabs. This model, in addition to the database and the user interface, is all run locally on a Raspberry Pi, and results from the YOLO detection system are saved onto the Raspberry Pi to allow for future retraining of the YOLO models to improve consistency and to improve accuracy.
First, the tab is cleaned using a rotary brush and a small amount of solvent. An integrated splash guard has been attached to the rotary tool to mitigate operator exposure during the cleaning process. A final wipe is performed to dry the surface and clear away any extra black mass. Once the tab is clean, it is slid to the vision end of the system for inspection. An image is then captured on the vision end and processed using a computer vision model to classify the tabs as clean or unclean. The result is recorded, enabling a more consistent, traceable workflow.
The system demonstrates improved consistency and reduces cleaning time by approximately 50% based on observed operation. The rotary brushing process provides more repeatable surface preparation, while the integrated inspection allows for each tab to be classified and logged through the user interface. This allows for a more controlled and traceable workflow. We'd like to thank our MSD guide Oliver Miller, our client team at the Battery Development Center, and Ian Brooks for lab support.